Hello students, are you able to hear me?
Yes, ma'am.
Yes. Okay. Good evening. So my name is Richa Patil and I am your science teacher. I'll be teaching you chemistry for this academic year. So what do you mean by chemistry? Yes, what do you mean by chemistry? What do you mean by chemistry? Yes.
Ma'am, to study about substance matters.
Yes, study about substance matter. Then are you using this chemistry in your day-to-day life? Are you using chemistry in day-to-day life? Is it useful for you all?
Yes, ma'am.
How can you tell me how you're using in day-to-day life? Yes. So the morning, okay, the since you get up in the morning, right? So the water you drink, right? What is that? It is H2O. It is what? It is nothing but it is a compound of water molecule, right? So it is also a chemistry, right? Then toothpaste, right? Early morning you use toothpaste. So that is what? So that is also a product obtained from chemical, right? So that is also a part of chemistry. Then soap you use, detergent you use, right? So these are your day-to-day you use in the regular life, right? Then the paints you use, right? So these are all your uh, it is a part of your regular life, right? You're using it in the day-to-day life. So before going to your this year's chapter, right? So you will brief some of the basic terms what you have studied. So last year you have studied some of the chapters like matter, right? Matter in our surroundings, right? Then is matter around us pure? Then you have studied about atoms and molecules. Then you have studied about structure of atoms, right? So these are some of the topics you have already learned. So what you'll be studying this year? So this year you'll be studying what? You are mainly you're going to study this 4 chapters in chemistry. So I'll be dealing with these 4 chapters. So the first chapter is what? Chemical reactions and equations. Second chapter is acid, bases, and salts. Third, metals and non-metals. Fourth, carbon and its compound. Okay, so these are the chapters we are mainly going to study in this particular year. So before going to the main chapters, so we'll study some of the basic terms. So we are going to study some terms like atoms. Okay, what are atoms? What are molecules? What are elements? What are compounds? Okay, we are going to study the electronic configuration of first 20 elements. Then we are going to see the structure of atom. Okay, then we are going to see valency. What is valence electrons? Okay, how to write the chemical formula. So these are some of the basic terms we are going to discuss in this particular class. Okay. So how ions are formed, we are going to see how ions are formed. What are ions? Okay, if you know how ions are formed, then you will be able to write the formula of some of the ions by knowing its charges. Okay, charges are important, so you need to know the charges. So if you know or if you remember the charges, then by this you will be able to write the chemical formula. Okay. So first, we'll start with what? We'll start with atoms and molecules. Okay, what are atoms? What are molecules? So what is atoms? Yes, what is atoms? So atom is what? Atom, it refers to the smallest constituent unit of a chemical element. Okay, it is the smallest particle of matter of an element. Okay, so atom. So you know in your periodic table, there are 118 elements, right? So all are elements. So out of this all elements, it is what atom is. It is the smallest constituent unit. Okay. So for example, hydrogen atom. right? So hydrogen atom, it is the smallest constituent unit of matter of an element. What do you mean by matter now? Matter is what? Matter is something which occupies space and which has a definite mass, right? So that is nothing but your matter. So what is atom? It is the smallest constituent unit of a chemical element. Okay, so you can see this is a atom of oxygen. So atom of oxygen, what it consists of? It consists of 3 protons, 3 electrons, 3 neutrons. So we'll be discussing about what are protons, what are electrons, what are neutrons in our coming slides. Okay, so first understand what is atom. It is the smallest constituent unit of or smallest particle. Okay, remember it is the smallest particle of matter of an element. Okay, now what do you mean by molecule? Okay, you can see what is molecular. So molecule means nothing but it is referred to a group of 2 or more atoms. Okay, so it is made up of group of 2 or more atoms. So when 2 or more atoms, they join together or they come together with the help of a chemical bonds. Okay, with the help of a chemical bonds, then they are said to be a molecule. So it is, you can see in the blue, okay, blue diagram here. So what is a molecule? So here the example is taken of water. Okay, water molecule. How water molecule is formed? Water molecule is formed by combining of 2 hydrogen atoms with 1 oxygen atom. So this is a molecule. Okay, what is atom? It is the smallest particle of a matter of a element. And what is molecule? It is a group of 2 or more atoms when they are combined or which are held together due to chemical bonds. Okay, so this is atom and molecules. Okay, so other example for molecules, you can give me other example of molecules. Yes, other example of molecules. Just a second. Okay, so H2, for example, H2 molecule. Okay, H2 molecule is what? So it is combining of 2 hydrogen atoms. So how this H2 molecule is formed? So one hydrogen atom, okay, it combines with another hydrogen atom, forming what? Hydrogen molecule. So this is hydrogen molecule. Okay, so like this it forms a, so it is held together by a chemical bond. So this is one atom, hydrogen atom, this is another hydrogen atom, and this is a hydrogen molecule, H2 molecule. Okay, so these are atom and molecule. Okay, so another example, oxygen, O2, right? So F2, Cl2. So these are different molecules or different okay, examples of molecules. So we'll go for the next one. So you can see here, so there's something called as, in molecules you can see 2 types. Okay, so one is homoatomic. What do you mean by homoatomic molecules? Molecules we have understand. Okay, we have understood what are molecules now. So it is what? It is made up of 2 or more atoms, okay, which are held together by a chemical bonds, right? So molecules. What is homo? Homo means what? Same. Okay, it is same, and atomic means same atom. So when 2 same atoms, okay, when same atoms, they form homoatomic molecules. So when the same atoms they combine, they form what? Homoatomic molecules. For example, nitrogen, you can see here N2. So N2 molecules. So when 2 nitrogen atoms, when 2 same atoms combine, they form homoatomic molecules. So here they are N2. The next example is O2, between 2 oxygen atoms when they combine. Here is fluorine. Okay, when 2 fluorine atoms when they combine, so they are between the same atom. Okay, then chlorine, between 2 same chlorine atoms. Okay, so these are the examples of what? Bromine. Okay, so these are the examples of what? Homoatomic molecules. Okay, these are the examples of homoatomic molecules. Homo means same atoms. Then next is heteroatomic molecules. What do you mean by heteroatomic molecules? Hetero. Yes, what do you mean by heteroatomic molecules? Hetero means what? Different, between different atoms. Okay, when they form from the molecules, okay, they are formed between different atoms. For example, here carbon dioxide, okay, water, ammonia, methane. Okay, water H2O, ammonia is NH3, carbon dioxide is CO2, methane is CH4. So between what? So there are different atoms. So there are two hydrogen atoms plus one oxygen atom, so giving you a heteroatomic molecule, water. Okay, so here what? One nitrogen atoms and three hydrogen atoms, giving you ammonia. So hetero means what? Different atoms. Okay, when molecules are formed by between different atoms. Carbon dioxide, one carbon and two oxygen atoms. Okay, methane, one carbon plus four hydrogen atoms. So this is heteroatomic molecule. So this is the meaning of heteroatomic molecule. So what is the atom is what? Atom is the smallest particle in a matter of a element. Okay. And what is molecules? Molecule is made up of two or more atoms. Okay. Which are held together by chemical bonds. So in molecules, there can be two types. One is homo. Okay. It can be between same atoms. The molecules can be formed between same atoms, or heteroatomic molecules, that is between different atoms. So, okay, so this is the difference between homoatomic molecules and heteroatomic molecules. Now, next is what? Next is atomicity. Okay, what do you mean by atomicity? So what do you mean by atomicity? So you can see here, okay, it tells you about the number of atoms in a molecule. Okay, so your atomicity of some elements. So you can see, okay, argon, helium. Okay, so what is the representation? Argon, Ar, helium is He. So these are non-metals. Okay, so remember, whenever you have non-metals, okay, non-metals, and so these are what? First are what? Argon and helium are called as what? What are argon and helium called as?
Noble gas.
Yes, they are called as noble gases, right? So argon and helium are noble gases. So along with some non-metals like oxygen, hydrogen, nitrogen, chlorine, phosphorus. Okay. So so this what is that? Argon, helium. Okay, they never form diatomic molecules. Argon, helium, never they form diatomic molecules. They are always in monoatomic form. They do not react. Okay, these noble gases, they do not react. So these are what? These are in the monoatomic form. Then non-metals like oxygen, hydrogen, nitrogen, chlorine. Okay, you can see these are in what? These are in diatomic form. Okay. You can see here, right? So these are in diatomic. So diatomic means what? Two, right? So oxygen, two atoms of oxygen combined, right? So then they are called as diatomic. Okay. So these are the examples of diatomic. Then non-metals like phosphorus. Okay, phosphorus, it forms what? Tetra. Okay, it forms a tetra. Okay. So this is phosphorus. It forms a tetraatomic. Okay. Then here sulfur, it is octa. So when you have more than 4, then it is called as polyatomic. So sulfur, it is in S8. So always metals. So remember that always, okay, always metals and noble gases. Okay, always metals and noble gases occur in monoatomic form. Okay, they form in monoatomic form. So argon, helium. Okay, then the metals like sodium, iron, aluminium. Okay, then copper. So these are all your monoatomic. So most of the your non-metals, they form diatomic, polyatomic forms. Okay, so atomicity, okay, it tells you the number of atoms, okay, present in the molecule. Okay, so these are some of the example. Then we'll be discussing about what are elements and compounds. Okay, what are now elements and compounds? So you can see what is an element now. So what is element? Yes, what is element? What do you mean by element?
When same types of atoms come together to form an element.
Yes. So when same type of atoms they combine, okay, so so it is combining to form new elements. Okay, so that is, it is a substance that is made entirely of only one type. Okay, so for example, now sodium, if you have a sodium element, so sodium element means what? It consists of what? Sodium element. Sodium element means what? It is made up of all sodium atoms. So when all sodium atoms they combine, okay, they form sodium element. So sodium element means what? It is made up of, it is a substance which is made up of only one type of, okay, it is made up of entirely one type of atom. So this is an example for your element. Okay, so this is an example for element. So that is sodium element. What do you mean by now compound? What do you mean by compound? What do you mean by compound? So compound, it is what? It is a substance. Okay, compound is a substance which is made up of two or more different elements, right? So what is the difference between element and compound? So element means what? It is made up of entirely one type of atom. Okay, and compound means what? It is made up of two or more different elements. Okay, can you give me example for compound? Can you give me example for compound?
H2O.
Yes,
Water.
H2O. Yes, H2O is an example for compound. Then NaCl. Okay, NaCl. So these are the example of compound. So when different, what two or more different elements. Okay, here you can see one sodium element and one chloride. Okay, here you can see two hydrogen atoms and one oxygen atom. So they combine to give you a compound. So this is a example of your compound. Okay, then we'll see some examples. Just a second. Okay, so I'll give you a list of molecules. Okay, okay, so you have to tell me. So O2, then H2O, H2, HCl, NH3, and N2. So in this, which are elements and which are compounds? Yes. So you have to tell me which are elements and which are compounds.
O2, H2 and N2 are elements, and H2O, HCl and NH3 are compounds.
Yes. So yes, right. Okay. So these are the elements and these are the compounds. Good. Okay. So I hope you have understood the difference between atom molecules, then elements and compounds. Okay. So you can see here, right, how are the elements formed? So molecule of elements. So when two hydrogen atom form, right? So this is a molecule of hydrogen. So two oxygen atoms, they combine to form a molecule of oxygen. Okay, and two chlorine atoms. Okay, so when they combine, they form a molecule of chlorine. So what do you mean by element? So it is made up of only one type of atom. Okay, so next is molecule of compounds. Okay, here you can see, so two hydrogen atoms, they combine with what? Oxygen atom to form a molecule of water, right? So this is example for compound. Then one hydrogen atom and one Cl, right, atom, they combine to give you a molecule of hydrogen chloride. Okay, so this is a example of compounds. So next we'll study the structure of atom. Okay, next we'll study the structure of atom. So structure of atom, what you are studying in structure of atom? So you know what is atom? So atom is the smallest particle of matter of an element, right? So this atom, okay, so you are going to study the structure of atom. So in the structure of atom, so the central part, okay, centrally there is a presence of what? The central, okay, centrally there is a nucleus which is present, okay, central. So I'll just, if you want, I'll draw here. So in the center of an atom, so there is what? There is nucleus present. You can see here, this is a nucleus which is present in the center of an atom. Okay. And this nucleus is surrounded by shells. Okay. You can see it is surrounded by what? It is surrounded by this shells. Okay. So these shells, okay, in which what are present? In which there are electrons. You can see the minus sign, right? So these are your electrons which are surrounded, and these electrons are surrounded in different orbits. Okay. So centrally what is present? Centrally nucleus is present, and okay, around the nucleus what is present? So these are called as what? These are shells. Okay, these two, this and okay. So these are called as shells, or they are called as orbits. So in the center, there is nucleus. Around the nucleus, there are shells, or they are called as orbits. Okay. So this, which is towards the nucleus. Okay. This is towards the nucleus. So the shell. So different shells are present. So here the number of shell goes on increasing. Okay. Based upon the number of electrons which are filling like this. So number of orbital goes on, orbits increases. So this is called as first shell. This is called as second shell. This is called as third shell. This is called as fourth shell. So same way, meanwhile, it is called, they have given the name as K shell, L shell, M shell, N shell, and so on. Okay. So next to the nucleus, okay, next to the nucleus, the shell which is present, it is called as inner shell. What it is called as? It is called as inner shell. And the last shell, okay, the last shell which is present, it is called as what? It is called as outer shell, or it is called as valence shell. Okay, what it is called? Outer shell or valence shell. So what is structure of atom? What is atom? It is the simplest particle. Okay, it is the simplest particle, or it is the smallest particle. So what is present in the center of an atom? Nucleus is present in the center of an atom. Okay, so which is positively charged. So nucleus is positively charged. So around the nucleus, what is present? The shells are present. Okay, these are called as shells or orbits. Okay, so in these shells, what are present? Electrons are present, which are present in different orbitals. Okay, then how the shells are numbered? So the nucleus, near to the nucleus, it is called as first shell, and subsequently it is called as second, third, fourth. Okay, they are given the name as K, L, M, N. So nearer to the nucleus, the shell which is present, first shell, it is called as inner shell, and the last shell, okay, it is called as the outer shell or the valence shell. Now we'll talk about the nucleus. So in nucleus, what is present? Okay, so nucleus, it comprises of protons and neutrons. Okay, so nucleus in the center, which is positively charged, it comprises of what? It comprises of proton and nucleus. Okay, so this protons and neutrons together, they are called as what? They are called as nucleons. Remember this term. So protons and neutrons together, they are called as what? They are called as nucleons. Okay. So what are the charges now? So proton has a positive charge. So proton has a positive charge, and neutron has a neutral charge. Okay, what do you mean by neutral charge? Not positive, not negative. Okay, it has a zero charge. So nucleus, what consists of? It consists of protons and neutrons. Protons, what is the charge? It is a positive charge. Neutrons, it has a neutral charge. Neutral charge means no positive, no negative. It is a zero charge. Okay. So protons and neutrons together, they are called as what? They are called as nucleons. Okay. What they are called as? They are called as nucleons. So then in the shells, what are present in the shells? In the orbits or shell, there are electrons, right? Electrons are present. So what is the charge on electrons? So electrons is negatively charged. Okay. Electrons is what? Electrons is negatively charged. So this is the structure of an atom. Okay. So this is the structure of an atom. So shells also, you have I've told you what are they called as subsidingly. First, second, third, fourth shells are there. So it is named as KLMN. Okay. So the shell which is close to the nucleus is called as what? Inner shell, or it is named as K shell, and the shell which is okay at the far or at the outer this, so it is called as outer shell, or it is called as the valence shell. Okay. I hope you're understanding. Yes. If you have any difficulty, you can ask me. You have understood this much?
Yes, ma'am.
Yes. Shall I proceed then? Okay. So next we'll see how do you represent. So you know there are different elements in the periodic table, right? So how do you represent them? Okay. How do you represent the element? So the element is represented by X. Okay. The any element, it is represented by its symbol. Okay. So symbol. So I have taken the symbol as X. So any element, it is represented by its symbol. So here I have taken just X. In general, I have taken X. Okay. Then here at the bottom, you write the atomic number. Okay. So at the bottom, there will be atomic number. And at this left hand side, it is written as atomic mass number. Okay. Atomic mass number. So we are going to discuss what is atomic number and what is atomic mass number. Okay. So what is atomic number and atomic mass number? So now, so first we'll discuss what is atomic number. Okay. So what is atomic number? So atomic number, how to calculate the number of, okay, how to calculate atomic number. So suppose now in a proton, okay, in a proton, if you have, so if in a proton, there are 3 charges. Okay. So so remember, so this is a nucleus and it is surrounded by shells. Okay. So if in the center it has, if it has 3 positive charge, okay, if it has 3 positive charge, okay, if it has 3 positive charge, then it should be balanced by 3 negative charge, that is by 3 what is that, 3 electrons. Okay. So I'll represent it with another color. So here, so like this. So always 3 charges should be balanced by 3 negative charge. Okay. So atomic number is what? Atomic number can be calculated by the total number of protons. Right. What is positive charge? Positive charge is nothing but your total number of protons, or it can be calculated by total number of electrons. Okay. So this is the way you're going to calculate the atomic number. So you know that always, okay, the positive charge is compensated by negative charge. So here, so if there are 3 positive charge, there should be 3 negative charge. So always, okay, in any element when you are writing, so there are, if there are 3 positive charge, that means there are 3 negative charge. So atomic number, it represents what? It represents the total number of protons or total number of electrons. So it can be calculated by using total number of protons or total number of electrons. Okay. So that is atom. Okay. Atom is equal to what? Positive charge or is equal to negative charge. So number of positive charge is equal to number of negative charge. So remember this. So atom always, it consists of the number of positive charge, it will be equal to number of negative charge. Okay. If the number of positive charge is not equal to negative charge, that means it will be in ion form. Okay. Whenever you are representing an element, always in an atom, positive charge will be equal to negative charge. If the positive charge is not equal to negative charge, that means it is in the form of ion. Okay. Ion. Okay. So next we'll see. So this is your atomic number. What is atomic mass number? Now this atomic number, okay, so X. Atomic number is represented by what? Z. Atomic number is represented by Z. What is atomic number? Total number of protons or total number of electrons. Next is atomic mass number. Atomic mass number, it tells you total number of protons plus total number of neutrons. Okay. Total number of protons and total number of neutrons. So that together are called as what? Or it is what? Simply total number of nucleons or total number of nucleons. Okay. So how do we calculate atomic mass number? Total number of protons plus total number of neutrons or simply total number of nucleons. You know, protons and neutrons together are called as what? They are called as nucleons, right? So atomic mass number is calculated like this. So always remember, so protons and electrons will be same. The number of protons and number of electrons will be same. Sometimes the number of neutrons will be same or different. Okay. It is not always that number of neutrons will be also same. In some condition, it will be same or it will be different. Okay. So atomic mass number. So how the atomic mass number is represented? It is represented by A. Okay. It is represented by capital A. Okay. So this is about the structure of atom. So we'll go for the next one. So next we'll see, you need to remember the electronic configuration of first 20 elements. Now, what do you mean by electronic configuration? Okay, what do you mean by electronic configuration? Oh, yes, what do you mean by electronic configuration? So it is what? It is a distribution of electrons. Okay, it is a distribution of electrons in different or in various molecular orbitals in a molecule is called as electronic configuration. So you can see this is a positively charged nucleus in the center. So it is surrounded by different orbits or shells. Okay, these orbits or shells are represented by K, L, M, N, or they are simply named as 1, 2, 3, 4, etc. So how the electrons are filled? Okay, so the electrons are filled from lowest energy level to highest energy level. So in K shell, the maximum number of electrons filled will be 2. Okay. Then in the L shell, 8. Okay. So then 18. So like this, the number of shells, it goes on, increases. Okay. Now just see K shell, the number of. So now we'll see the electronic configuration for first 20 elements. Okay. So the first 20 elements are, which are the first 20 elements? So hydrogen, right? Hydrogen. So this is very important. You need to remember the electronic configuration from hydrogen to calcium. Okay. So these are the first 20 elements. Okay. So hydrogen, helium, lithium, beryllium. Okay. Then your boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, then your potassium, okay, and your calcium. So these are the first 20 elements. So the number of okay, so the the number of electrons. So in hydrogen, the number of electron is what? 1, right? So in helium, it is 2, right? Number of electrons are 2, right? Then lithium, it is what? It is lithium is what? 3. The number of electrons are 3, right? So K, so this will be in K shell, this will be in K shell, right? So these are the first electronic configuration. So 2 and 1, okay. So this is also K shell, then 2, 2. So this is K shell, then third electron, it goes in the next shell, so it will be L, right? L also. Then in L shell, the number of electrons maximum filled will be 8, okay. In K, the number of electrons will be 2, L, okay, it will be 8. So this is K, L, okay, the number of electrons are 4. So first 2 electrons will be filled in K shell, next 2 in the L. So then boron 2 and 3. So K, L. Then this also 2 and 4, okay, K, L. then this is L. Okay, then this 2 and 8. Okay, so this is your shell L, it gets completed. Okay, next it goes to 1. So it is K, L, and M shell, right? It goes to the next shell. So like this, you are going to fill the electrons. So how the electronic configuration or electrons you are going to fill? It is from lowest energy level to highest energy level. Okay, so remember the electronic configuration. So, so this is the way you are going to fill up the electron. So remember this electronic configuration. So you just see. So after filling, why it is stopping at 8? Because it is completing its octet. Okay, you know what is octet? So octet means what? It wants to it will be in stable form. Always whenever the electrons are filled, it wants to be in stable form. So it will not take the next electron. The next electron will be gone to the next shell. Okay, main shells. So this is 2, 8, then 2. Then again the electron will go in the here it is 2, 8, 3, then 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8. Okay, so it stops at 8 again here. So it you can see in calcium. Okay, in potassium, it does not becomes 2, 8, 9. Okay, it becomes what? It is 2, 8, 8, 1. Okay, because it is following the octet rule, right? It wants to complete it octet, and then the next substituent electron will be filled in the next shell. So it is then calcium, it is 2, 8, 8, 2. Okay, so like this, the electronic configuration are filled. Okay, so this is the electronic configuration of first 20 elements. So next is what we mean by valency and what we mean by valence electrons. What is valency? So it is the capacity of an atom, okay, of the atom of an element to form chemical bonds. So valency is nothing but it tells you about the capacity of an atom of an element to form the chemical bonds. What is valence electrons then? So these are the electrons. So whenever the electrons which are present in the valence shell, what do you mean by valence shell? Valence shell is nothing but your outer shell. Okay, it tells you about the outer shell. So it tells you about the outer shell. So the number of electrons which are present here in the outer shell, they are called as what? They are called as the valence electrons. Then what is valence shell? So valence shell is what? The outermost shell of an atom is called as its valence shell. So the outermost shell, okay, the outermost shell of an atom is called as the valence shell. So these are the terms you need to remember. So we'll see for an oxygen atom, okay, when you write the valency and valence electrons, okay, we'll see what are valency and what is valence electron. So oxygen, so name of the element here is oxygen. The atomic number of oxygen is 8, okay, 8. The symbol of oxygen is O. Then the atomic weight is 15.9. Atomic weight is nothing but your mass number, okay, atomic mass number, it is 16. 15.9 is nothing but your 16. Then electronic configuration, how you fill up the electrons. So 8 electrons, 1s2, 2s2, 2p4. So you can see at the center there is what? This is a nucleus which is present in the center. Then subsequently what is present? Orbits are present or shell is present. So in the first shell, the maximum number of electrons filled are what? They are 2. Right. So you can see there are 2 electrons which are filled here. Right, there are 2 electrons which are filled here. Then it goes to the next shell. The number of electrons filled in the next shell is how many? 8 electrons can be filled. So, but the number of electrons available in oxygen are how many here? They are 6. So 1, 2, 3, 4, 5, and 6. Okay, so there are 6 electrons which are filled in the next next orbit. Okay. So here, so it is 2 and 6, right? 2 and 6. So what is the valence electrons? What is called, how many valence electrons are present now? What do you mean by valence electron? The number of electrons in the valence shell. How many valence electrons are present in the valence shell?
6.
Yes, 6 valence electrons are present. Now, how to calculate the valency? Okay, I forgot to tell you about this, how to calculate the valency. See, remember always, so whenever you have number of valence electrons, okay, if the number of valence electrons are only from 1 to 4, Okay, when the number of valence electrons are 1 to 4, that is valence electrons are less than 4. Okay, when the valence electrons are less than 4, then valence electron is equal to your valency. So how many valence electrons are there? No, that is your that will be equal to your valency. Okay, when you have the valency from 1 to 4. Okay, and if you have the valency from more than 4. Okay, if you have more than 4, that is when the number of valence electrons are more than 4, then valency can be calculated as, how do you calculate valency? 8 minus valence electrons. Okay, so this is the way you're going to calculate the valency. So now the number of valence electrons are how many here? They are 6. How do you calculate the valency? Yes, how do you calculate the valency? It is more than 4. So how will you calculate the valence electrons? Valency?
8 minus 6.
8 minus
It's
6.
two.
So it is how many? Yes, it is 2. Okay, so the number of valence electrons is 2. Now you know oxygen. Okay, oxygen, if it takes, so it will take how many? It wants 2 electrons. Okay, to complete its octet, it will take 2 electrons. So it will have what? It will have -2 charge. So negative charge means what? It will gain electrons, right? If it takes electrons, then it will have a negative charge, and if it gives electron, it will have a positive charge. Okay, so your oxygen, the charge will be what? It is represented as -2, because to complete its octet, it requires 2 more electrons. Okay, so this is the this is about the valency and valence electrons. So same way, if I tell you about sodium now, yes, can you tell me for sodium? Yes, number of this is how many sodium? It is 2, 8 and 1. Okay, so the number of atomic number is 11. So can you tell me
Valency is 1, ma'am.
valency is how much?
1.
1. And valence electrons?
1.
Yes, 1. So to complete, so you know it is complete, the octet is complete. Okay, so if it wants to be stable, what it will do? It will give this 1 electron. So if it gives this 1 electron, it will lose 1 electron. So it will have what charge? It will have not here. So it will, the charge will be what? It will be +1. Okay, +1 will be the charge for sodium. Okay, so this is the valency and valence electrons. So now how ions are formed? Okay, how ions are formed? How ions are formed? So ions are formed by addition of electrons or by removal of electrons from a neutral atom. Okay, so when you are adding the electrons, okay, so what it is called when you are adding electrons, then it is called as what? When you are adding electrons, it is called as an ion. Okay, when you are adding electrons, it is called as an ion. When you are removing the electrons from a neutral atom, then it is called as cation. Okay, remember these terms. What are ions? Okay, whenever you are adding any electron, then they are called as anions. So it will have a what? Addition of electrons will result into a negative charge. Okay, addition of electron will result into a negative charge, and removal of electron will result into a positive charge. So this is what? This is cation and this is an ion. Okay, so this results into ions. Now you can see the example, sodium atom. So I said you, so it wants to be in its octet state. So what it will do? It will tend to give this 1 electron, the outermost electron it wants to give. Okay, to be in the most stable form. So it will give the electron and it will be in plus state. Okay, so it will be removal of electron. So this results into what? It results into cation. So sodium is a, so Na plus is a sodium cation. Okay, then here you can see chlorine atom. So the number of electron present is 2, 8 and 7. So 7 means what? It wants 1 electron to complete its octet. Octet means what? The number of electron present should be 8. So it wants 1 electron to complete its octet. So what it will do? It will tend to take this 1 electron from the sodium. Okay, and so when it is taking the electron, when it is adding electron, it forms what? It forms an ion. Okay, so it will have a negative charge. So it becomes what? Cl minus. Okay, so Na plus and Cl minus. So remember the terms cation and anion. Cation is what? Cation is when it removal of electron results into cation. and addition of electron results into an ion. Okay, so these are the ions. Then see here, so neutral atom, when there is a loss of electron, then it is called as cation. Okay, when there is loss of electron, it is called as cation. When there is gain of electron, then it is called as anions. Okay, remember this terms. Okay, so these are the ions, cations and anions. Then what is polyatomic ions? What do you mean by polyatomic ions? So it is an ion which is composed of more than one atom. So whenever there is more than one atom, okay, then it is called as polyatomic ions. The ammonium ion consists of one nitrogen atom. Okay, ammonium is what? NH4 plus. Okay, NH4 plus. So NH4 plus. Okay, NH4 plus. So it consists of one nitrogen atom and 4 hydrogen atom. Okay, it consists of 4 hydrogen atom. Together they comprise a single ion with a positive charge and a formula of NH4 plus. So this is what polyatomic ion. So it is made up of, this is a single ion which is made up of a positive charge. So there is one nitrogen atom and 4 hydrogen atom. So together they made up of a polyatomic ion. So there are more than 4 atoms are present. So together, so this is a polyatomic ion. Okay, so it is made up of a single ion with a positive charge. Okay, so these are positive polyatomic ions. So you can see some of the positive ions, cations. Okay, how they are represented: hydrogen H plus, sodium Na plus, silver Ag plus, okay, potassium K plus, lithium. So these are some of the cations. So always they will tend to give the electrons. Okay, always remember the electropositive atoms. Okay, electropositive atom means what? In the periodic table. Okay, on the periodic table to your left hand side, that the elements which are present, they are the electropositive atoms. Okay, so sodium, potassium, then your lithium, aluminum. So these are all monoatomic. You can see monoatomic means what? There is only +1. Okay, +1. So they are called as monoatomic or monovalent. Okay, then barium, calcium, copper, magnesium, zinc, lead, iron 2. Okay, iron 2, it is called as ferrous, and iron 3 is called as ferric. Okay, whenever you have +2 state, it is that is +2 state in iron, then it is called as ferrous, and +3 is called as ferric. Aluminium +3. Okay, so it is monovalent. Then these are bivalent ions, and then these are the trivalent ions. When they have 3, okay, +3 charge, it is called as trivalent. Then you can see some of the negative ions or anions. Chloride Cl minus, bromide is Br minus, fluoride is F minus, iodide is I minus. Okay, then what? Hydroxide is OH minus, nitrate is NO3 minus, oxide is O2 minus. Okay, sulfide S2 minus, sulfate SO4 2 minus, carbonate CO3 2 minus, hydrogen carbonate CHCO3 minus. So you need to remember the charges. Okay, you need to remember the charges of positive ions and negative ions. So if you know the charges, then you'll be able to write the chemical formula. Okay, so you need to remember the charges of the positive ions and negative ions. If you know the charges, then it will be easy for you to write the chemical formula. So next we'll see how to write the chemical formula. So this is one example. Okay, next you have to solve. So this is iron 3. Iron 3 means what? Ferric. Okay, ferric hydroxide. Okay, ferric hydroxide. So ferric hydroxide, what is the symbol for iron? It is Fe. Okay, the symbol for iron is what? It is Fe. Fe, and the symbol for hydroxide is OH. Okay, it is OH. Now you need to remember the charge. So Fe, ferric. Okay, they have given +3. So the charge is +3. Okay, and the charge for hydroxide is -1. Okay, so they are unequal charges. So always what you have to do, whenever there is unequal charges, you have to crisscross. Crisscross means what? You have to just crisscross, okay, cross the charges. Then so what you'll get? Fe, okay, and this in bracket OH thrice. So like this, you have to write the chemical formula for the different compounds. Okay, so this is one example. So can you write it for the next one for aluminium oxide? For aluminium oxide, for aluminium oxide.
Ma'am, Al2O3. Ma'am, your voice is actually muted.
Okay, so when you're writing the symbol, okay, symbol aluminium Al and oxide is O, right? Then what is the charge? What is the charge for aluminium? It is +3 and oxygen is -2. Next step is what? You have to crisscross the charge, and what will be the this? It will be Al2O3, right? So this is aluminium oxide. Yes. So we'll go for the next one. You can tell me this one. Calcium oxide. Yes. Calcium oxide.
Ma'am, CaO.
Yes. See here. Calcium is represented by Ca. Oxygen oxide is represented by O. What is the charge for calcium? It is +2. Charge for oxygen is -2. So they are similar. Okay. They are similar charges. So there is no need for crisscrossing. It will get cancelled off, right? +2 -2 get cancelled and it becomes CaO, right? Okay. So we'll go for the next one. Okay, next is iron carbonate. Next is iron carbonate. Iron carbonate. So symbol iron is Fe. They have given carbonate is what? CO3. Okay. The charge for iron is +3. Carbonate is -2. So crisscross, it becomes Fe2CO3 thrice. Understood? So here the main, this is you need to remember the charges. Okay, you need to remember the charges. Once you know the charges, then you'll be able to write the chemical formula. Okay, so you need to remember the charges. So whenever there are unequal charges, unequal charging means what? Both the element, they have different charges, then you have to crisscross it. Okay, you have to crisscross. If they have same, it will get cancelled off. Okay, so this is the chemical formula for iron carbonate. So I'll give you some more. You have to write for sodium oxide. Sodium oxide. Yes, sodium oxide. Sodium. What is the symbol?
Ma'am, Na2O.
Yes. Sodium is what? Na. Oxide is O. Okay. Then the charge for sodium is +1. Oxygen is -2. So they are unequal charges. So you crisscross it. So it becomes Na2O. Okay. So this is for sodium oxide. Okay. So next we'll one more. Aluminium chloride. Okay. The name is aluminium chloride. Aluminium chloride. Yes. Aluminium chloride.
Ma'am, AlCl3.
Yes. So aluminium, it is represented by Al. Chloride is Cl. Aluminium, the charge is +3. Cl, the charge is -1. So there are unequal charges. So you need to crisscross it. Okay. So it will be AlCl3. Yes. Good. Okay. So next is magnesium. Okay. Magnesium hydroxide. Magnesium hydroxide. Magnesium hydroxide. Symbol. Charge. Yes.
Ma'am, Mg in bracket OH2.
Yes. Symbol. Mg. Okay. Magnesium is Mg. Hydroxide is OH. The charge for Mg is +2. Hydroxide is -1. So you have to crisscross. You get MgOH twice. Okay. So this is the chemical formula for magnesium hydroxide. A last Na sodium sulfide. Sodium sulfide. Sodium sulfide. Symbol. Charge.
Ma'am, Na2S.
Yes, correct. Good. So sodium Na, sulfide is S, Na is +1, sulfide is -2. So crisscross it. It is Na2S. Good. Panchami, right? Yes. Okay. So good. So we'll stop for the day. So we'll continue in the next class. Thank you. We'll meet in the next class.